Next, let us move on to the topic of dipole moment. Okay, so first, what is a dipole? Two charges, equal and opposite charges placed a distance apart, is called a dipole. Okay, why should we learn about dipoles? See, water molecule is O and H, right? So we know that O is slightly electronegative, so there is a slight negative charge here. On H, there is a slight positive charge. Okay, so this H2O molecule is like a dipole, slight negative, slight positive, like this. Net charge is zero on the water molecule. And because water molecule is a dipole, when we add salt to water, that is sodium chloride, Na plus comes here and Cl minus comes here, and salt dissolves in water. Many chemical reactions taking place in aqueous solutions, many biological chemical reactions taking place within us take place because water molecule is a dipole. So our existence is because water molecule is a dipole. So that is why it is important to learn what is a dipole and what is dipole moment. Okay, so let us move further and see what is dipole moment. So we discussed there is a minus q plus q separated by some distance. Let us say this is 2a. Why 2a? In standard textbooks it is given like this, so we take it like that. Okay, so from the center this charge is at a, from center this charge is at a, so separation is 2a. So this constitutes a dipole, and there is one quantity called dipole moment we associate with this pair of charges, and that dipole moment we write it like this: P equal to the charge, any one of the charge, times the distance between them. Okay, so this is called dipole moment. So let me just write down this. This is called dipole moment. This is a value of any one charge, because the charge is equal and opposite, the value of any one charge. And this is the separation between charges. Okay. So now, what are the SI? Let us see some SI units and what is the quantity, vector, or scale. So SI unit, what is the SI unit of this? So charge coulomb meter. Okay, and what quantity is this? This is a vector quantity. Okay, this is a vector quantity. And what is the direction of this vector quantity? It is from negative to positive charge. Okay, see, you remember electric field lines go from positive to negative. This dipole moment vector is from negative to positive. Okay, from negative to positive charge. You might get confused, negative to positive charge. Let us see another definition actually of this dipole moment, so that you won't get confused with this direction also. See, for a system of charges, till now we know that this is a dipole, this is dipole moment, this will be followed everywhere. In the dipole concept, everywhere this will be followed. But remember this also, for a set of charges, for a set of point charges, dipole moment about an origin is given by, let us write this, okay, P bar equal to summation QI RI bar. So this is the definition of dipole moment for a set of charges about the origin. And let us see how this comes from this. Okay, see, these are the two charges, and suppose this is our origin. Okay, so you just first join this here, and next join this. This is R minus, okay, and this is R plus. So now what is the dipole moment of this charge combination of charges? P bar equal to, this first is Q R plus bar plus summation. So this is minus Q R minus bar. Okay. So how can I write this as P bar equal to Q into R plus minus R minus, or P bar equal to Q into, see what is this vector R plus minus R minus? So R plus minus R minus is this vector. Okay, that is nothing but 2A. Okay, so even if you forget where is the direction from negative to positive, just remember that this is a basic definition, and from here also you can get the direction. Okay, next let us move on to concept level questions in this topic. So we have two charges, minus Q and Q, and Q is located at 1 comma 2 comma 1, and minus Q is located at 0 comma 1 comma 0, such that they form an electric dipole, the dipole moment vector formed by the pairs. Okay, so what is the dipole moment vector? P bar equal to any one of the charge times the vector is from here to here. Okay, so directly what is this vector? R A bar minus R B bar. So this is what I cap plus 2j cap plus k cap minus, this is 0 I cap plus minus j cap. That's it. Okay, it is this vector. So directly P bar equal to Q times I cap plus j cap plus k cap coulomb meter. Okay, this is coulomb meter. You might think it as centimeter. I'll write C big and M small. Okay, suppose we have many such dipoles in space. Okay, so the net dipole moment is what? P bar. So suppose this is P1 bar. Okay, this is P2 bar, this is P3 bar, P4 bar, and so on. So the net dipole moment of all these dipoles is P bar equal to P1 bar plus P2 bar plus P3 bar plus P4 bar. Vector quantity, so it adds vectorially, and the net dipole moment is nothing but the sum, vector sum of all the dipole moments. Let us move on to the next question. So there is a charge distribution given here, and we need to find the net dipole moment. Okay, so there is a minus 3q, q, and q here. Okay, so can we say, I'll just divide this minus 3q into minus q here, minus q here, and another minus q. Okay, so can we say that this q and minus q will form a dipole? This q and minus q form a dipole, and this one will form a dipole. Okay, so what is the dipole moment of this from negative to positive? Okay, from negative to positive, and this is from negative to positive. Okay, so if this is a vector quantity, we said that net dipole moment is the vector sum. So this vector will be q into a here, q into a here, and both in opposite direction, so they will cancel out. So we just have this one, so that will be, so net dipole moment is equal to q into a, in which direction? In this, suppose this is x and this is y, we can say q into a gk. That's it. Okay, suppose we were to do by the other method. Other method is just do summation qi ri. We can do like that also. P bar equal to q1 r1 bar plus q2 r2 bar, like that. So minus 3q, our origin is here, let us say. So here it will be 0. Then we can do q into what you call a. So I'll just write down here. So this will be minus 3q into this is anyways 0 bar null vector plus q into a I cap. This will be plus q into A minus I cap plus Q into A j cap. So anyways, this gets cancelled, these both get cancelled, and directly you have Q into A j cap. Okay. Next, again a similar question. Find the dipole moment of this charge distribution. So there is one charge distribution here, another charge distribution here. Okay. So in this four charges, can we say that this will form one dipole? Okay. And this forms another dipole. The dipole moment magnitude is same in their opposite in direction. So net dipole moment in this case is 0. Okay. Now let us look at this. Dipole moment is from negative to positive. Here negative to positive. So both add up. So dipole moment here is P equal to Q into A, and there are two of these dipoles. Okay. So 2Q.